Hello, welcome to the Science to Sleep channel. I'm really glad you're here. Maybe today was long, well, maybe your mind is still busy, or maybe you're just someone who likes to fall asleep thinking about distant planets and quiet moons instead of counting sheep. Either way, you're in the right place. For now, you don't need to do anything. Let your breathing slow down. Let your thoughts loosen their grip. Let your body feel a little lighter, as if gravity has eased off and you've started to drift. Tonight, we're not rushing anywhere. We're gently wandering through the solar system. Not in straight lines, but in soft curves, past sunlit planets and dusty rings, overshadowed craters and frozen oceans, hiding beneath ice. This is a story told without numbers or pressure. A story told through magnetic storms, tilted worlds, and moons that glow quietly in the dark. From sideways planets and diamond rain to ancient sunlight still crossing the void, every orbit holds something strange and beautiful. We'll take it slowly, one calm fact at a time. And before we begin, if these quiet journeys help you unwind or give your day a softer ending, you can gently tap like or subscribe. It helps others find their way here too. One sleepy mind at a time. Now, let's begin. Neptune's winds move faster than sound. Even though Neptune sits at the far edge of the solar system, it hosts the fastest winds of any planet. In its upper atmosphere, winds can race past 2,000 kilometers per hour, faster than the speed of sound on Earth. That's several times faster than a commercial jet. These powerful winds are likely fueled by Neptune's internal heat, which still escapes from within despite the planet's icy surface. Composed mainly of hydrogen, helium, and methane, Neptune's atmosphere twists these winds into massive storms that ripple through pale blue clouds, a frozen world always in motion. Mars holds a canyon the size of a continent. Stretching more than 4,000 kilometers across Mars, Valles Marineris is the largest canyon system in the solar system. It would span the entire width of the United States. In some places, it drops more than 7 kilometers deep, far deeper than the Grand Canyon. Scientists believe it formed as Mars' crust cracked and pulled apart, shaped by tectonic stress, volcanic activity, and erosion. It's a scar across the planet's surface, a reminder that Mars was once far more restless than it appears today. Venus has no magnetic field. Although Venus is similar to Earth in size and composition, it lacks a global magnetic field. On Earth, molten iron moving inside the core creates a protective magnetic shield. Venus's core appears sluggish or possibly solid, unable to generate the same effect. Without that protection, solar wind has steadily stripped lighter elements from its atmosphere. This missing shield may be one reason Venus transformed from a potentially Earth-like world into the furnace we see today. Diamonds may fall as rain on Uranus and Neptune. Deep inside Uranus and Neptune, pressures and temperatures may be extreme enough to create diamond rain. These icy giants contain thick layers of methane. Under immense pressure, methane molecules may break apart, freeing carbon atoms that compress into tiny diamonds. Laboratory experiments support this idea. If true, storms of glittering crystals could be drifting through the deep blue darkness far below their clouds. Earth is the only planet with active plate tectonics. One of Earth's most important features is its system of shifting tectonic plates. These slow-moving slabs of crust shape mountains, trigger earthquakes, and recycle carbon dioxide, helping regulate the planet's climate over millions of years. No other planet shows clear evidence of this process. Earth's moving surface may be one of the quiet reasons life has been able to last here for so long. Some asteroids have their own moons. Asteroids aren't always lonely travelers. Some have tiny moons of their own. These small companions may be captured fragments or pieces that form together. The first discovered asteroid moon, Dactyl, was spotted orbiting asteroid Ida in 1993. Since then, many more have been found. Even the smallest bodies can form gentle partnerships, drifting together through space. Mercury has a ghost-like exosphere. Mercury doesn't have a true atmosphere. Instead, it's surrounded by an extremely thin exosphere, where atoms float freely without colliding. These atoms come from the surface, knocked loose by solar wind and micrometeor impacts. Sodium, potassium, and oxygen drift briefly before escaping into space. The result is a faint, shimmering shell, more suggestion than substance. The Sun loses millions of tons of mass every second. At its core, the Sun fuses hydrogen into helium, releasing energy that powers the solar system. Every second, about 4 million tons of mass are converted into light and heat. Over billions of years, that loss adds up. Yet for now, the Sun burns steadily, quietly giving part of itself to keep everything else alive. Saturn's rings are slowly fading away. Saturn's rings look eternal, but they aren't. Ice particles from the rings are gradually falling into the planet, pulled by gravity and magnetic forces. Data from the Cassini spacecraft suggests the rings may be relatively young and could disappear in a few 100 million years. A beautiful temporary feature in a very long story. Mars can be swallowed by dust storms. Sometimes dust storms on Mars grow so large they cover the entire planet. These storms can last for weeks or months, blocking sunlight and reshaping the surface. In 2018, one such storm ended the mission of the Opportunity rover. Even without oceans or rain, Mars is still an active, unpredictable world. Europa may hide a salty ocean beneath its ice. Beneath the cracked surface of Jupiter's moon Europa, evidence suggests a vast ocean of liquid water. Tidal forces from Jupiter generate heat, keeping the ocean from freezing solid. Chemical traces and magnetic signals hint at salty water below. In the darkness beneath the ice, conditions may exist that could support life. Mars has a volcano taller than Everest. Olympus Mons rises nearly 22 kilometers above Mars, making it the tallest volcano in the solar system. It grew so large because Mars lacks plate tectonics, allowing magma to erupt in the same spot again and again. The result is a silent giant dominating the Martian landscape. Saturn's rings are surprisingly thin. Though they stretch hundreds of thousands of kilometers wide, Saturn's rings are often less than 100 meters thick. Made mostly of ice, they can nearly vanish when seen edge-on, like a sheet of glass turned sideways. Earth is the densest planet. Earth packs more mass into its volume than any other planet. Its dense metal core plays a key role in generating the magnetic field that protects life from solar radiation. The Sun hums like a musical instrument. The Sun vibrates with slow pressure waves, far below human hearing. Scientists study these oscillations to understand what's happening inside. In a quiet way, the Sun is always singing. Venus spins backward. Venus rotates in the opposite direction of most planets, and very slowly. One day on Venus is longer than its year. The reason remains uncertain, but the result is a world with an entirely different rhythm. Jupiter has more than 90 moons. Jupiter isn't just a planet, it's a miniature system. Dozens of moons orbit it, from large worlds to tiny captured rocks, all bound by immense gravity. Mercury hides ice in permanent shadow. Despite extreme heat, ice exists inside deep craters near Mercury's poles. Shielded from sunlight, these frozen pockets have survived for millions of years. Pluto's heart may conceal an ocean. Beneath Pluto's heart-shaped plane, there may be a hidden ocean kept liquid by internal heat. Even in the cold outer reaches, water may quietly persist. The asteroid belt is mostly empty space. Despite dramatic images, the asteroid belt is vast and sparse. A spacecraft could pass through without ever seeing a rock nearby. It's more emptiness than danger. Ancient building blocks that never quite became a planet. Uranus doesn't just orbit the sun, it rolls. Most planets spin like tops, tilted slightly on their axis. Uranus, however, is tipped almost completely over, with an axial tilt of about 98 degrees. Instead of spinning upright, it essentially rolls along its orbit. Because of this extreme tilt, each pole faces the sun for about 42 years straight, followed by 42 years of darkness. The exact cause is still debated, but many scientists believe Uranus was knocked sideways by a massive collision early in its history. This strange orientation gives Uranus one of the most unusual and unpredictable climates in the solar system. Jupiter's radiation belts are deadly. Jupiter is wrapped in the strongest magnetic field of any planet. Inside that field are intense radiation belts, far more powerful than Earth's Van Allen belts. These zones are packed with high-energy charged particles, trapped by Jupiter's magnetism. Unprotected spacecraft passing through them would be quickly damaged or destroyed. Even Jupiter's largest moons are constantly exposed, which affects their surfaces and potential habitability. Any mission operating near Jupiter must carefully plan its path or use heavy shielding. It's a stunning world, but surrounded by invisible danger. The Sun contains nearly all the mass in the solar system. At the center of everything, the Sun dominates not just with light, but with weight. It holds over 99.8% of the total mass of the solar system. All the planets, moons, asteroids, comets, and dust combined make up less than 1/4%. That enormous mass creates the gravity that keeps everything in orbit, from rocky worlds nearby to distant objects in the Oort cloud. It also fuels the fusion reactions at the Sun's core, turning hydrogen into helium and filling space with energy. There are more dwarf planets than classical planets. Beyond Neptune lies a scattered population of icy worlds. Pluto is the most famous, but it's far from alone. Eris, Haumea, and Makemake are just a few others, with many more candidates still being discovered in the Kuiper Belt and beyond. In fact, dwarf planets may greatly outnumber the 8 classical planets. These small round worlds are ancient leftovers from the solar system's formation, largely unchanged for billions of years. Cold and distant, they quietly preserve the past. A day on Venus lasts longer than its year. Venus rotates incredibly slowly. It takes 243 Earth days to complete a single spin on its axis, but only 225 days to orbit the Sun. That means one full day on Venus is longer than a full year. This slow rotation contributes to extreme surface conditions with temperatures hot enough to melt lead. Combined with crushing pressure and a thick, acidic atmosphere, Venus is a world of relentless heat and endless daylight. Titan has lakes made of methane. Saturn's largest moon, Titan, is the only place besides Earth known to have stable liquids on its surface. But on Titan, those lakes and rivers aren't water. They're made of liquid methane and ethane. Its thick, nitrogen-rich atmosphere supports weather systems, including methane rain and seasonal storms. Some lakes stretch for hundreds of kilometers. Beneath the icy crust, scientists suspect a hidden ocean of water may exist. Titan feels strangely familiar. yet completely alien. The moons of Mars may be captured asteroids. Mars has two small misshapen moons, Phobos and Deimos. They look more like asteroids than typical moons, irregular and heavily cratered. Many scientists think they were once asteroid belt objects captured by Mars's gravity. Their strange shapes and low densities support this idea, though other theories exist. Phobos is slowly spiraling inward and will one day break apart or crash into Mars. Deimos is drifting away. They are quiet remnants of a chaotic past. Jupiter glows with its own heat. Jupiter gives off more energy than it receives from the Sun. This extra heat comes from leftover energy from its formation and from slow gravitational contraction. That internal warmth powers Jupiter's violent storms and swirling cloud bands. In infrared light, the planet glows like a smoldering ember beneath its clouds. It's not a star, but it came surprisingly close. With just a bit more mass, Jupiter could have become a failed sun. Neptune was discovered through math. Neptune wasn't found by chance. Astronomers noticed tiny irregularities in Uranus's orbit that couldn't be explained. Two mathematicians working independently in the 1840s calculated where an unseen planet must be. When telescopes were pointed there, Neptune was waiting. It was the first planet discovered on paper before being seen in the sky, revealed by numbers alone. Saturn's North Pole has a hexagon. At Saturn's North Pole, a massive six-sided cloud pattern spins endlessly. This hexagon is wider than Earth and has persisted for decades, possibly much longer. Scientists believe it forms from stable atmospheric waves created by Saturn's rapid rotation. Similar shapes can appear in laboratory fluid experiments. Seeing such clean geometry emerge naturally in a planet's atmosphere remains one of the solar system's most surreal sights. The Sun's atmosphere is hotter than its surface. The Sun's visible surface is about 5,500 degrees Celsius, but above it, the outer atmosphere, called the corona, reaches temperatures of over 1,000,000 degrees. How it gets hotter farther from the core is still not fully understood. Magnetic waves and tiny explosive events called nanoflares may be responsible. Either way, the Sun's outer layers burn with mysterious heat. The Kuiper Belt is full of icy worlds. Beyond Neptune stretches the Kuiper Belt, a vast region filled with frozen remnants from the solar system's birth. Pluto, Eris, Haumea, and Makemake all live here among countless smaller objects. It's like the asteroid belt, but colder, darker, and richer in primordial ice. A frozen archive of the early solar system. The Oort cloud may extend nearly a light-year away. Far beyond the Kuiper Belt lies the hypothetical Oort cloud, a distant shell of icy debris surrounding the solar system. It may stretch almost a light-year from the Sun and is thought to be the source of long-period comets. These objects drift in deep space for billions of years before a passing star or galactic tide sends them inward. If it exists, the Oort cloud marks the Sun's true gravitational frontier. Io is the most volcanic world in the solar system. Jupiter's moon. Io is constantly erupting. Its surface is reshaped by lava and molten sulfur, creating vivid yellows, reds, and blacks. Some plumes rise hundreds of kilometers into space. This activity is driven by tidal heating as Jupiter's gravity squeezes and stretches Io again and again. Unlike Earth's slowly cooling crust, Io's surface is young, unstable, and endlessly active. Triton orbits Neptune backward. Triton moves in the opposite direction of Neptune's rotation, suggesting it was captured long after the planet formed. That capture likely disrupted Neptune's original moons. Triton is also geologically active. with icy volcanoes and a thin atmosphere that changes with the seasons. Cold, distant, and moving against the flow, Triton refuses to behave like a typical moon. Earth's moon is unusually large. Compared to its planet, Earth's moon is enormous. No other rocky planet has such a large companion. Most scientists believe it formed after a Mars-sized body collided with early Earth, throwing debris into orbit that eventually became the Moon. This close partnership has shaped Earth's tides, climate, and long-term stability. The Moon is more than a satellite. It's a reminder of a violent beginning. Planetary orbits aren't perfect circles. Planets travel in elliptical paths, not perfect circles. This means they move closer to and farther from the Sun during their orbit. For some planets, the difference is subtle. For others, like Mercury and Pluto, it's dramatic. These variations affect seasons, sunlight, and orbital speed. Johannes Kepler first described this motion in the 1600s, revealing the solar system's elegant geometry. Some comets come from the edge of interstellar space. Long-period comets are thought to originate in the Oort cloud. They may spend billions of years drifting in darkness before being nudged toward the Sun. When they arrive, they blaze briefly across the sky, carrying untouched material from the solar system's earliest days. The Sun will one day become a white dwarf. In about 5 billion years, the Sun will run out of hydrogen fuel and expand into a red giant. After shedding its outer layers, the remaining core will become a white dwarf, slowly cooling for trillions of years. A quiet ember marking the end of a long stellar life. Mars has seasons like Earth. Mars is tilted much like Earth, giving it familiar seasons. Spring, summer, autumn, and winter unfold more slowly, because a Martian year is nearly twice as long. These seasons drive dust storms, polar ice changes, and shifts in atmospheric pressure. Ganymede is the largest moon in the solar system. Jupiter's moon Ganymede is even bigger than Mercury. It has a rocky core, a possible subsurface ocean, and its own magnetic field. Beneath layers of ice, multiple oceans may exist, stacked like hidden worlds. Massive, quiet, and distant, it orbits deep inside Jupiter's grasp. Pluto sometimes orbits closer to the Sun than Neptune. Pluto's orbit is highly elliptical. Between 1979 and 1999, it was actually closer to the Sun than Neptune. Thanks to orbital resonance, the two never collide. Their paths are locked in a precise gravitational dance. The Sun flips its magnetic field every 11 years. Roughly every 11 years, the Sun's magnetic poles reverse. This cycle drives changes in sunspots, solar flares, and space weather that ripple across the solar system. At the peak of the solar cycle, known as solar maximum, the Sun becomes noticeably more active. Radiation increases, magnetic storms grow stronger, and space around Earth gets louder in invisible ways. As the cycle slowly winds down, activity fades, settling into a quieter phase called solar minimum. These rhythms affect Earth's upper atmosphere, satellites, and the auroras that ripple across polar skies. The Sun's magnetism isn't rigid or fixed. It shifts, pulses, and relaxes like a slow magnetic breath expanding and contracting over time. Planetary alignments don't cause natural disasters. Despite how often the idea appears, there's no scientific evidence linking alignments to earthquakes, floods, or global chaos. The gravitational pull of other planets on Earth is tiny compared to the Moon or the Sun. Even during rare alignments, their combined influence barely registers. The moon, simply by being close, has far more effect on tides and internal stresses than distant giants like Jupiter or Saturn. Alignments are visually striking and mathematically elegant, but physically harmless. A quiet cosmic choreography, not a warning sign. Leaving the solar system takes decades. Escaping the sun's influence isn't something you do quickly. Spacecraft like Voyager 1 and 2, launched in the 1970s, only recently crossed into interstellar space, where the heliosphere gives way to the interstellar medium. It took them more than 40 years, traveling faster than 60,000 kilometers per hour. They passed the planets, drifted through the Kuiper Belt, and kept going into the dark, still transmitting, still listening, carrying a golden record filled with sounds of Earth. Slow, patient messengers moving outward, one silent mile at a time. Earth's magnetic field quietly protects us. Surrounding the planet is an invisible magnetic shield created by the movement of molten iron deep within Earth's core. This field deflects charged particles from the sun, guarding our atmosphere and surface from constant radiation. Without it, solar wind would slowly strip the air away, much like what happened to Mars. Some particles slip through near the poles, painting the sky with auroras in green, red, and violet. It's not static or perfect, but it's enough. A living barrier that has preserved life and climate for billions of years. The moon is slowly drifting away. Each year it moves about 3.8 centimeters farther from Earth, pulled outward by tidal interactions between ocean and orbit. Long ago, the moon hung much closer in the sky, appearing larger and brighter. As it recedes, Earth's rotation slows, days lengthen, and eclipses become rarer. Far in the future, total solar eclipses will no longer happen at all. The change is subtle, almost unnoticeable, but the sky is not fixed. It's quietly evolving, along with us. The Kuiper Belt holds icy worlds that shine like mirrors. Beyond Neptune, this distant region contains not only dwarf planets, but smaller bodies with surprisingly bright surfaces. Haumea spins fast, stretched into a football shape and coated in crystalline ice. Eris reflects so much sunlight it appears brighter than fresh snow. These surfaces may be renewed by impacts, chemistry, or icy volcanism. Out there, at the edge of sunlight, some worlds don't fade into darkness. They glint softly, catching what little light reaches them. Enceladus throws water into space. Saturn's small moon hides an extraordinary secret beneath its icy shell. From cracks near its south pole, towering geysers of water vapor and ice erupt outward. These plumes are powered by tidal heating, friction caused by Saturn's gravity keeping a subsurface ocean liquid. Within the spray are organic molecules, salts, and signs of hydrothermal activity. Some of this material escapes and feeds Saturn's E-ring, a tiny moon quietly connecting ocean, space, and planet in a continuous exchange. Some asteroids are barely holding together. Not all are solid rock. Many are loose collections of gravel and dust, gently bound by gravity. These rubble piles often form after violent collisions when fragments slowly reassemble. They can shift shape, spin strangely, and contain vast empty spaces inside. Missions like Hayabusa 2 and OSIRR-ISR-EX confirm just how fragile they are. These aren't solid relics, they're drifting ruins, leftovers of construction that never quite finished. Mercury's core is far larger than expected. Though the planet itself is small, its iron core makes up most of its interior, far more than Earth or Venus. Why remains uncertain. A massive impact may have stripped away its outer layers, or early solar forces may have favored heavy materials near the sun. What remains is a thin crust wrapped around a dense heart, giving Mercury a weak magnetic field and a strangely unbalanced interior. A survivor shaped by extremes. Venus has no moon at all. Among the rocky planets, only Mercury and Venus orbit alone. Mercury's closeness to the Sun offers one explanation, but Venus is harder to explain. Similar in size to Earth, yet without a companion. Some theories suggest a moon once existed and was lost through collision or decay. Others point to Venus's slow backward rotation preventing stable orbits. Whatever the reason, Venus circles the Sun by itself, bright, cloud-covered and solitary beneath its pale sky. Most moons belong to the giants. Earth has one moon. Mars has two small ones. But beyond the asteroid belt, the gas giants host sprawling families of satellites. Jupiter and Saturn have dozens, ranging from captured rocks to massive worlds like Ganymede and Titan. Uranus and Neptune add their own icy companions. These planets behave like miniature solar systems, their gravity collecting debris and shaping orbits over time. The farther out you go, the more company gravity seems to gather. Hubble watches the planets from Earth orbit. Though it circles close to home, the Hubble Space Telescope has captured detailed views of Jupiter's storms, Neptune's winds, and seasonal changes on Mars. These long-term observations reveal shifting atmospheres, glowing auroras, and evolving weather patterns. From a quiet orbit above Earth, Hubble doesn't just look outward to distant galaxies. It keeps an eye on our neighbors, watching them slowly change. Jupiter's Great Red Spot has endured for centuries. This vast storm has churned in Jupiter's southern hemisphere for at least 350 years, wide enough to swallow multiple Earths. First seen through early telescopes, it has slowly shrunk but remains powerful. Winds race around its edges at hundreds of kilometers per hour. Its color likely comes from complex chemistry stirred by sunlight and altitude. While storms on Earth fade quickly, this one persists, locked within Jupiter's endless turbulence. Neptune gives off more heat than it receives. Despite its distance from the Sun, Neptune radiates over twice as much energy as it absorbs. This internal heat fuels violent winds, the fastest in the solar system. The source remains unclear, possibly leftover formation energy or slow internal contraction. Beneath its cold exterior, Neptune is active and restless, a quiet blue world, driven by hidden warmth. Earth holds water in all its forms. Ice, liquid, and vapor exist together across the planet, cycling through oceans, clouds, and land. This balance depends on distance from the Sun, atmospheric pressure, and long-term stability. Other worlds may hide water underground or freeze it in place, but none share Earth's global exchange. Here, water moves constantly, flowing, freezing, rising, falling, a system that sustains life through motion. The heliopause marks the Sun's outer boundary. As solar wind expands outward, it eventually meets interstellar gas and dust. Where the pressures balance, the heliopause forms, defining the edge of the Sun's energetic influence. Voyager 1 crossed it in 2012, Voyager 2 in 2018. Beyond lies true interstellar space. The Sun's gravity reaches farther, but here its breath finally fades. The solar system is drifting through a cosmic cloud. We are moving through the local interstellar cloud, a thin region of gas and dust shaped by ancient supernovae. As the Sun travels, its heliosphere shields us from this material. Studying this environment helps scientists understand cosmic rays, space weather, and long-term climate effects. We are not stationary. We are quietly sailing through a galactic mist. Some moons are geologically alive. Activity isn't limited to planets. Io erupts with volcanoes. Enceladus vents water. Europa and Ganymede likely hide warm oceans beneath ice. Even Triton shows signs of icy eruptions. These worlds are not frozen relics. Beneath their surfaces, energy moves, reshaping them from within. Pluto's atmosphere appears and disappears. When Pluto nears the Sun, surface ice turns to gas, forming a thin atmosphere. As it drifts away, that atmosphere freezes back onto the surface. This cycle repeats over its long orbit. During New Horizons flyby, Pluto was wrapped in a delicate blue haze, a brief exhale from a world that spends most of its time in deep cold. The Sun's core is unimaginably hot. At its center, temperatures exceed 15 million degrees Celsius. Here, hydrogen fuses into helium, releasing the energy that lights our world. That energy takes hundreds of thousands of years to reach the surface, then just 8 minutes to cross space to Earth. Calm light born from intense pressure and heat. Uranus has faint, tilted rings. 13 dark rings circle the planet, aligned with its extreme tilt. Viewed from certain angles, they appear almost vertical. Narrow and sharply defined, some are shaped by small shepherd moons. Discovered only in 1977, they remain subtle and shadowy. Rings wrapped around a planet lying on its side. The heliosphere is the Sun's protective bubble. Solar wind flows outward, forming a vast magnetic shell around the solar system. It shields planets and distant objects from galactic radiation. Shaped by both solar activity and interstellar pressure, it travels with the Sun through the Milky Way, a moving barrier guarding everything within it. Mercury helped confirm Einstein's gravity. Its orbit shifts in a way classical physics couldn't explain. In 1915, general relativity solved the puzzle, showing how massive objects warp space and subtly alter motion. Mercury's strange path became proof that space itself bends. The small but measurable shift in Mercury's orbit matched Einstein's predictions with remarkable precision. It became one of the first real-world confirmations of his radical theory, a quiet victory for mathematics that explained a strange detail in the motion of a scorched rocky planet. A subtle wobble, noticed carefully, ended up reshaping how we understand gravity itself. The moon shapes Earth's tides. The steady rise and fall of the oceans is driven mostly by the moon's gravity. As it pulls on Earth, it creates bulges in the oceans, one facing the moon and one on the opposite side. As Earth spins, coastlines move through these bulges, creating high and low tides. The Sun also plays a role, strengthening or weakening tides depending on alignment. Beyond the water, tidal forces gently flex Earth's crust and even influence its rotation. The moon never speaks, but it keeps the oceans moving. There may be undiscovered planets beyond Neptune. Astronomers have noticed that some distant Kuiper belt objects follow unusual clustered orbits that don't quite fit existing models. One idea is that an unseen massive planet, often called Planet 9, could be shaping these paths through gravity alone. If it exists, it would be several times Earth's mass and orbit far beyond Pluto, taking thousands of years to circle the Sun once. No direct evidence has confirmed it yet, but the search continues. Finding it would quietly rearrange the map of the outer solar system. Callisto may hide an ocean beneath its ice. Jupiter's moon, Callisto, looks old, battered, and geologically calm. But beneath that frozen shell, a liquid ocean may exist, kept warm by internal heat left over from formation. Data from the Galileo spacecraft hinted at a conductive layer below the surface, consistent with salty water. If confirmed, Callisto would join Europa and Ganymede as another ocean world. Less famous, less dramatic, but potentially just as important. A dark ocean, sealed under time and ice. Venus is hotter than Mercury, despite being farther from the Sun. Mercury sits closer, yet Venus holds the heat record. The reason is its thick carbon dioxide atmosphere, which traps heat in a runaway greenhouse effect. Surface temperatures soar above 460 degrees Celsius, hot enough to melt lead. Clouds reflect sunlight, but they also lock warmth in. Mercury, with almost no atmosphere, loses heat quickly when night falls. Venus proves that distance alone doesn't decide a planet's fate. Atmosphere matters more. Saturn's rings are mostly ice. Though they look solid, the rings are made of countless individual particles, mostly water ice, ranging from dust grains to house-sized chunks. They orbit in a thin, flat disk shaped by Saturn's gravity and nearby moons. Ice gives the rings their brightness, making them one of the most reflective structures in the solar system. Gaps, waves, and narrow ringlets form through gravitational resonances. The rings are not static. They are motion frozen into shape. Ceres is both asteroid and dwarf planet. Sitting between Mars and Jupiter, Ceres is the largest object in the asteroid belt, large enough to be round and earn dwarf planet status. Discovered in 1801, it may contain a subsurface layer of salty water or mud. NASA's Dawn mission revealed bright surface spots, later identified as salt deposits left behind by evaporating brines. Ceres is neither full planet nor simple rock. It's a hybrid world, preserving early building blocks of planetary history. Mars looks red because of rust. Its surface is coated in fine iron oxide dust, formed as iron reacted with oxygen over billions of years. This dust is everywhere, coloring the ground, the sky during storms, and the planet's overall appearance. Beneath the red, darker volcanic plains and polar ice add contrast. But from afar, rust wins. Mars broadcasts its chemical past in color. Some dark patches on the sun are cooler regions. Sunspots appear darker, not because they're cold, but because they're cooler than their surroundings. Strong magnetic fields there block heat from rising. These spots can grow larger than Earth and often appear in groups, following the sun's 11-year activity cycle. Even at their coolest, they remain blisteringly hot, their marks left by magnetism, scars that reveal the sun's restless interior. Uranus was discovered by telescope. Unlike planets known since antiquity, Uranus wasn't officially identified until 1781, when William Herschel spotted it through a telescope. At first it seemed like a star or comet, but its motion gave it away. This discovery expanded the known solar system and marked a shift into modern astronomy. Since then, Uranus has kept surprising us with its tilt, rings, and icy moons. A quiet planet that changed the rules. The solar system is about 4.6 billion years old. By studying meteorites and ancient rocks, scientists traced its age back to a collapsing cloud of gas and dust. The sun formed first, pulling material inward. The rest slowly gathered into planets, moons, asteroids, and comets. Collisions were common. Chaos was normal. What remains today are the survivors of that long, violent beginning. Vesta has layers like a planet. More than a simple asteroid, Vesta is a protoplanet. With a crust, mantle, and metallic core, it once held enough heat to separate into layers, a process known as differentiation. A massive impact carved the Rhea Silvia crater, possibly exposing deeper material. Vesta is a fossil from an era when planets were still deciding what they would become. The moon has quakes, though it seems still the moon does tremble. These moonquakes come from tidal stresses, temperature changes, or impacts. Some last far longer than earthquakes on Earth. Instruments left by Apollo astronauts revealed this quiet activity. The moon may lack tectonic plates, but it isn't entirely dead. It has a slow, restrained heartbeat. Triton is a captured moon. Neptune's largest moon orbits backward, a clue that it didn't form there. It was likely captured from the Kuiper belt, disrupting Neptune's original system. That capture caused internal heating, fueling geysers that vent nitrogen into space. Triton carries scars of adoption, a stranger pulled into orbit, reshaped by gravity. Neptune has at least 14 moons. These range from large and complex to small and irregular. Triton dominates, but others follow strange paths. Many are dark, icy, and likely captured objects. Together they hint at Neptune's turbulent history, a scattered family around a distant planet. The Parker Solar Probe is touching the Sun. Launched in 2018, it flies directly through the Sun's outer atmosphere, enduring extreme heat and speed. Protected by its heat shield, it dives closer with each pass, studying solar wind and magnetic fields. It's not just observing the Sun, it's moving through it. Some meteorites on Earth came from Mars. Powerful impacts blasted Martian rocks into space, some eventually landing here. Scientists identify them through chemistry and trapped gases. These stones are natural samples from another planet, delivered long before spacecraft returned any. The Sun is mostly hydrogen and helium. These simple elements fuel fusion in its core, releasing enormous energy. Heavier elements make up only a tiny fraction, inherited from older stars. Beneath its brilliance, the Sun is surprisingly simple. Earth's tilt creates seasons. A tilt of about 23.5 degrees means sunlight shifts between hemispheres through the year. Without it, seasons would barely exist. This angle quietly controls climate rhythms across the planet. Jupiter's magnetosphere is immense. It stretches millions of kilometers and traps intense radiation. Fueled by metallic hydrogen, it creates auroras and shapes nearby moons. It's dangerous for spacecraft and fascinating for science. Planetary rings may be temporary. Over time, gravity and collisions pull ring material inward. Saturn's rings may be relatively young and eventually fade. What looks permanent may just be a brief moment. The moon's surface barely changes. Without weather or plate tectonics, its landscape preserves ancient history. Footprints may last millions of years. It's a record written in stone. Some icy moons may host hydrothermal vents. Beneath ice, warm oceans may touch rock. On Earth, such places support life without sunlight. If they exist elsewhere, they may be the best places to look beyond Earth. Sunlight takes a little over 8 minutes to reach Earth. The light warming your skin or filling the sky didn't just leave the Sun a moment ago. It began deep in the Sun's core, where nuclear fusion creates tiny packets of light called photons. Those photons spend hundreds of thousands of years slowly fighting their way outward, bouncing endlessly through dense, hot plasma. Only after reaching the surface do they finally escape, crossing about 150 million kilometers of space in just over 8 minutes. So when you watch a sunrise or glance at the midday sun, you're not seeing it live. You're seeing a brief echo of the past, sunlight that started its final journey before you even looked up. Europa's cracked ice may behave like tectonic plates. Jupiter's moon. Europa is wrapped in a thick shell of ice, etched with dark lines, ridges, and broken regions that look strangely familiar. These patterns suggest the ice may be shifting, breaking apart, sliding. and possibly even sinking beneath itself, much like tectonic plates on Earth. If that's true, Europa would be the only known world besides Earth with active plate-like motion. This movement could help cycle nutrients between the surface and the ocean below, improving the chances for habitability. The energy behind it likely comes from Jupiter's gravity, constantly flexing Europa's interior. It's a frozen moon, but far from frozen in time. Saturn is less dense than water. In a very imaginary cosmic bathtub, Saturn would float. Not because it's empty, but because its average density is lower than water's. Made mostly of hydrogen and helium, Saturn has enormous volume but relatively modest mass for its size. It's over 700 times Earth's volume, yet only about 95 times its mass. This low density gives Saturn a soft, diffuse structure, spinning so fast that it flattens at the poles and swells at the equator. It's a giant shaped gently by motion and gravity, more airy than it looks. Solar flares can disrupt technology on Earth. Solar flares are sudden, intense bursts of energy erupting from the sun's surface, often near sunspots. These events release powerful radiation across the electromagnetic spectrum, including X-rays and ultraviolet light. When aimed toward Earth, they can disturb the upper atmosphere, interfering with GPS signals, radio communication, and satellite systems. Strong flares can also trigger geomagnetic storms, which in rare cases may affect power grids. Earth's magnetic field protects us, but flares are reminders that the sun isn't a steady lamp. It's an active, unpredictable star that occasionally sends waves of energy racing across the solar system. The solar cycle shapes auroras. Auroras, those slow-moving curtains of green, red, and violet light near Earth's poles, appear when charged particles from the sun collide with Earth's magnetic field and atmosphere. These displays become more frequent and intense during periods of high solar activity, following an approximately 11-year cycle. During solar maximums, sunspots and flares increase, sending more particles toward Earth and fueling brighter auroras. During solar minimum, the lights grow quieter. The sun's shifting magnetism leaves its mark on our skies, painting them with gentle reminders that space itself is alive. Comet tails always point away from the sun. As a comet approaches the sun, its icy surface begins to vaporize, releasing gas and dust that glow in the sunlight. But the tail doesn't trail behind the comet like smoke behind a moving train. Instead, it always points away from the sun, regardless of the comet's direction. Solar wind and radiation pressure push the material outward, creating two distinct tails, a curved dust tail and a straight bluish ion tail. Together, they form a glowing signature shaped entirely by sunlight's invisible force. Some planetary moons form through violent impacts. Earth's moon likely formed after a massive collision between early Earth and a Mars-sized body over 4 billion years ago. Debris from that impact spread into orbit and slowly came together to form the moon. Similar origins are suspected for moons like Pluto's Charon. These dramatic beginnings contrast with moons captured later by gravity alone. There's no single recipe for moons. Some were born from fire and collision. Others gently caught and held. Their variety reflects the chaos of the early solar system. Voyager 1 carries a golden record into deep space. Launched in 1977, Voyager 1 is now farther from Earth than any other human-made object, traveling through interstellar space. Attached to it is a golden record, a phonograph disc holding sounds and images chosen to represent life on Earth. It includes greetings in dozens of languages, music from across cultures. and sounds of waves, birds, and laughter. Designed by a team led by Carl Sagan, it's meant for any intelligence that might someday find it. A message sent without expectation. A quiet hello from a small blue world. Earth shares its orbit with co-orbital asteroids. While Earth circles the Sun on its own path, it isn't completely alone. Small objects called co-orbital asteroids travel in stable patterns near Earth's orbit, shaped by gravitational balance. Some, known as Trojans, linger near stable points ahead of or behind Earth. Others trace slow horseshoe-shaped paths that keep them nearby without ever colliding. These companions are often temporary, captured and released over long stretches of time. Unseen, they drift along with us, fellow travelers around the Sun. Neptune hid in plain sight before its discovery. Long before 1846, it was likely seen but not understood. Its slow motion and faint glow made it easy to mistake for a distant star or confuse with Uranus. Even Galileo may have unknowingly observed Neptune in 1612, marking it as a fixed point of light. Only when astronomers noticed irregularities in Uranus's orbit did mathematicians predict another planet beyond it. Once telescopes were aimed correctly, Neptune was found almost immediately. It hadn't appeared suddenly. It had been there all along. The edge of the solar system isn't defined by gravity alone. The Sun's pull extends far beyond Pluto, reaching icy bodies in the Oort cloud. But scientists usually describe the boundary as the edge of the heliosphere, where the solar wind meets interstellar space. The heliopause marks where the Sun's magnetic influence fades. Gravity continues beyond, but this energetic edge tells a different story. It isn't a wall, just a soft transition into the space between stars. Planetary atmospheres slowly escape into space. Even thick atmospheres like Earth's are not permanent. Over time, light gases, such as hydrogen and helium, can leak away, drifting into space. This process is strongest on smaller planets with weaker gravity, like Mars and Mercury. Venus, lacking a strong magnetic field, has lost much of its atmosphere to solar wind erosion. Earth loses thousands of tons of hydrogen every year, though it's easily replaced. Still, it's a steady exchange, a quiet breathing between planet and void. Some moons may have formed from ring systems. Ring systems don't just fade away. In some cases, they can give rise to moons. Around Saturn, material beyond the Roche limit can clump together rather than being torn apart. Moons like Pan and Daphnis, which orbit within Saturn's rings, may still be gathering material today. These small moons shape the rings as much as the rings shape them, carving gaps and waves through gravity alone. Silent sculptors in orbit. Voyager 1 is still sending signals from interstellar space. More than 45 years after launch, Voyager 1 continues to send faint data back to Earth while traveling billions of kilometers away. Its instruments measure cosmic rays, magnetic fields, and the thin plasma between stars. Power is limited and systems are slowly shut down to conserve energy, but it still speaks. Using a small nuclear power source and the deep space network, each signal takes over 20 hours to arrive. A whisper from the farthest edge of exploration. The solar system completes a galactic orbit every 225 million years. While planets circle the Sun itself moves through space, orbiting the center of the Milky Way. One full rotation takes roughly 225 to 250 million years, sometimes called a cosmic year. Along the way, the solar system passes through different regions of the galaxy, drifting through clouds of gas, star-forming zones, and spiral arms. This motion may influence comet activity and, over immense timescales, even Earth's climate. We are not stationary. We are moving slowly through a vast spiral, and so this quiet journey comes gently to an end. From worlds scorched by sunlight to icy moons whispering in the dark, we've drifted together through gravity, motion, and time, one calm fact at a time. If your eyes feel heavy now, that's perfectly fine. Let the last bits of starlight fade behind your thoughts. Let your breath slow. There's so much more waiting out there, but it can wait until morning. You've traveled far enough for now. Thank you for being here. Under the quiet stars, the story continues. Sleep well.